Hey, this is Billy Atkins. This is going to be CPSC 2100 final exam. I'm going to make this a two-part and do the first three and then the last two on the next video. I'm going to go ahead and get into it since we already got everything uh, up and running. So for this problem, what we're going to do is we're going to lace these letters together, and it's going to constantly repeat, and whatever's left over, it's going to appear at the end. We'll try. We can also do with D2 if we want to, just to show since I already tested it there. But so this is going to take two strings in the function. This is going to be our placeholder, and we're going to start over I is equal to zero. So we're going to start on the zero character. While this function is running, while I is less than the string, while I is less than the length of the first string or the second string, if I if the zero is less than or if I is less than the length of string one, it's going to add that value to string one, and if it's less than two or the second string, which is also zero, it's going to add that string to it, add that add that and concatenate it, and I is going to increment one every time until it's greater than both of those or both the strings. And then once it, uh, and then at the end we'll return because that's what we'll do with, that's what we do with values. So hello world, it's going to concatenate S1 and S2. Let's see. Yeah, HW. Yeah, it's going to keep going back and forth and it'll just add to that end whatever's left over. All right. Then let's see. Okay. So this is prime numbers. You're gonna put it, we're putting in a number for n, and whatever number we put in, it's gonna count all the prime numbers up until that point. So this is gonna hold all of our prime numbers inside of a list. And we're gonna use a nested for loop. And the problem says for every a list of prime numbers between two and whatever that number is. So that's what we're putting in. Oh, sorry, wrong one. That's what we're putting in for between two and n. And then it's going to search through um, j, and then in that range from two to I. And if the modulus is equal to zero, it's going to break. And if it's not going to, then it'll end. Because prime numbers essentially is any number that's multiplied by one in itself. Like, for example, seven, it can only be one in itself. So if the remainder is equal to zero, then the whole program breaks until it reaches that point. And then if it doesn't, then it'll append that. And then this is just to sort the prime numbers, just to be sure. And then they'll return prime numbers. And then so you can put in the integer, and these are all the numbers. You can also do like 30, which yeah, 23 and 29 are also prime numbers too. That's basically how that works. Let me move this over. Okay, this one is okay. So this is our dictionary problem. We are we're given a dictionary that maps integer keys to integer values. Write a function that returns a list of the keys that map to the dictionary that appear exactly once. So if we create a dictionary that has 1 to 1, 3 to 2, 6 to 0, 7 to 0, 8 to 4, since one, um, 1, 3, and 8 only had values that appeared once, those are what we're going to get back, and it's going to be converted to a list. And then if we have 1, 1, 1, it will return nothing. Crap, go up. There we go. So these are unique values. This is going to create the list. This is going to hold the dictionary here, or the key in the list of dictionary keys. If the dictionary key value is not in the dictionary, it's going to set it equal to one, and else it'll count up inside a dictionary. It'll add to it. And then we're going to run another nested for loop. I is in dictionary's keys. If the dictionary at that element is equal to one, and then same thing essentially for J in the dictionary keys. If J is equal to I to that one, it's going to append it to the list, and we'll add it to that list. And this will print the original dictionary, and then this will print the sorted list. And then, so this was the one from the example, and then this is going to print that dictionary. And then we can, yeah, definitely. Okay. So I think that's everything. All right. Thank you.